This statement regarding air conditioners with a nameplate that reads max fuse size only, restricting the unit to fuse protection only, is not explicitly found in the 2002 National Electrical Code, referred to as the NEC. While the NEC handbook offers supplementary information and interpretations, it does not supersede the actual code. The NEC serves as the primary regulatory document for electrical installations, meaning any discrepancies between the handbook and the code itself are resolved by adhering to the NEC requirements. In the 2002 NEC, Section 440.21 outlines the overcurrent protection requirements for air conditioning and refrigerating equipment. These requirements are categorized into three main areas: firstly, branch circuit, short circuit, and ground fault protection; secondly, motor running overload protection; and thirdly, locked rotor current protection. The NEC does not contain a direct prohibition against employing circuit breakers with air conditioners that display a nameplate indicating max fuse size only. It is crucial to acknowledge that circuit breakers and fuses operate differently and may not offer identical levels of overcurrent protection. Consequently, adhering to the manufacturer's guidelines for the specific air conditioning unit being installed is paramount. To elaborate on the NEC Section 440.21, it's essential to understand the nuances of each protection category. Firstly, branch circuit, short circuit, and ground fault protection aims to safeguard the branch circuit wiring and equipment from short circuits and ground faults. This protection typically involves the use of fuses or circuit breakers with an interrupting rating sufficient for the available fault current at the equipment's location. Secondly, motor running overload protection is designed to protect the motor itself from overheating due to prolonged overloads. This protection is often provided by thermal overload relays or other devices that sense motor current and disconnect the motor from the power supply if the current exceeds a predetermined level for a specific duration. Thirdly, locked rotor current protection addresses the high current drawn by the motor when it is initially started or when it is stalled. This protection typically involves the use of fuses or circuit breakers with time delay characteristics that allow the motor to start without tripping the overcurrent device, while still providing protection against locked rotor conditions. When selecting overcurrent protection devices for air conditioning equipment, it is imperative to consider several factors. Firstly, the equipment's nameplate ratings, including the maximum fuse size or circuit breaker rating; secondly, the ampacity of the branch circuit wiring; thirdly, the available fault current at the equipment's location; and fourthly, the manufacturer's recommendations. It's crucial to select overcurrent protection devices that are properly sized and rated to provide adequate protection for the equipment and the branch circuit wiring. Failure to do so can result in equipment damage, fire hazards, or electrical shock. The NEC provides detailed guidance on selecting overcurrent protection devices for various types of equipment and applications. It is essential to consult the NEC and other relevant standards to ensure that the overcurrent protection system complies with all applicable requirements. While the NEC does not explicitly prohibit the use of circuit breakers with air conditioners that have a nameplate that reads max fuse size only, it is important to exercise caution when making this decision. Circuit breakers and fuses have different characteristics and may not provide the same level of protection in all situations. Fuses, for example, typically provide faster and more reliable overcurrent protection than circuit breakers. They are also less susceptible to nuisance tripping caused by transient overcurrents. Circuit breakers, on the other hand, offer the convenience of being resettable, which can be advantageous in certain applications. Ultimately, the decision of whether to use fuses or circuit breakers for air conditioner protection depends on a variety of factors, including the equipment's nameplate ratings, the available fault current, the desired level of protection, and the specific application requirements. It is essential to carefully consider all of these factors before making a decision. In addition to the NEC requirements, it is also important to follow the manufacturer's instructions for the specific air conditioner unit being installed. The manufacturer's instructions may provide additional guidance on selecting overcurrent protection devices and other components. In some cases, the manufacturer may specify the use of fuses or circuit breakers. It is important to adhere to these instructions to ensure that the equipment is properly protected. Regarding the NEC Handbook's role, it serves as a valuable tool for understanding and applying the NEC requirements. The handbook provides explanations, examples, and illustrations that can help clarify complex code provisions. However, it is important to remember that the handbook is not a substitute for the NEC itself. The NEC is the governing document for electrical installations, and any conflicts between the handbook and the code must be resolved in favor of the code. The NEC is updated every 3 years, and it is important to use the latest edition of the code. The NEC is available from the National Fire Protection Association, referred to as the NFPA, and other sources. The NEC is a comprehensive document that covers a wide range of electrical safety topics. It is essential for electricians, engineers, and other electrical professionals to be familiar with the NEC requirements. The NEC is designed to protect people and property from electrical hazards. By following the NEC requirements, it is possible to create safe and reliable electrical installations. In summary, when dealing with air conditioner protection, it is crucial to consult the latest edition of the NEC, adhere to manufacturer's instructions, and carefully consider the characteristics of both fuses and circuit breakers to ensure adequate overcurrent protection for the equipment and the electrical system. The NEC Section 440.21 provides specific guidelines for overcurrent protection of air conditioning and refrigerating equipment. The NEC Handbook is a helpful resource for understanding the NEC requirements, but it does not take precedence over the code itself. The NEC is the governing document for electrical installations, and any conflicts between the handbook and the code must be resolved in favor of the code. The decision of whether to use fuses or circuit breakers for air conditioner protection depends on a variety of factors, including the equipment's nameplate ratings, the available fault current, the desired level of protection, and the specific application requirements. It is essential to carefully consider all of these factors before making a decision. The NEC provides detailed guidance on selecting overcurrent protection devices for various types of equipment and applications. It is essential to consult the NEC and other relevant standards to ensure that the overcurrent protection system complies with all applicable requirements. The air conditioner nameplate ratings provide essential information for selecting the appropriate overcurrent protection. The nameplate will typically specify the maximum fuse size or circuit breaker rating that is permitted for the equipment. It is important to adhere to these ratings to ensure that the equipment is properly protected. The available fault current at the equipment's location is another important factor to consider when selecting overcurrent protection devices. The overcurrent protection device must have an interrupting rating that is sufficient for the available fault current. The interrupting rating is the maximum amount of current that the device can safely interrupt without failing. The desired level of protection is another factor to consider when selecting overcurrent protection devices. In some cases, it may be desirable to provide a higher level of protection than is required by the NEC. This can be accomplished by using fuses or circuit breakers with lower current ratings or faster tripping speeds. The specific application requirements are also important to consider when selecting overcurrent protection devices. For example, in some applications, it may be necessary to use fuses or circuit breakers that are resistant to vibration or corrosion. It is also important to consider the ambient temperature in which the equipment will be operating. The ambient temperature can affect the performance of overcurrent protection devices. The NEC provides guidance on directing overcurrent protection devices for high ambient temperatures. In addition to the NEC requirements and the manufacturer's instructions, it is also important to follow good engineering practices when selecting and installing overcurrent protection devices. This includes ensuring that the devices are properly sized, rated, and installed in accordance with all applicable standards. It also includes ensuring that the devices are properly maintained and tested on a regular basis. By following these guidelines, it is possible to create safe and reliable electrical installations that provide adequate protection for people and property. The types of fuses used in air conditioning and refrigeration equipment often include time delay fuses and dual element fuses. Time delay fuses, also known as dual element fuses, are designed to withstand temporary overloads such as those that occur when a motor starts without opening the circuit. They have a built-in delay that allows them to distinguish between harmless inrush currents and sustained overloads. Dual-element fuses typically consist of two elements. Firstly, a spring-loaded thermal cutout that responds to sustained overloads, and secondly, a short-circuit element that responds quickly to high fault currents. The thermal cutout provides overload protection, while the short-circuit element provides short-circuit protection. Time delay fuses are commonly used in motor circuits because they can prevent nuisance tripping caused by motor starting current. They are also used in other applications where temporary overloads are expected. The advantages of using time delay fuses include their ability to withstand temporary overloads, their ability to prevent nuisance tripping, and their ability to provide both overload and short-circuit protection. The disadvantages of using time delay fuses include their higher cost compared to standard fuses and their slower response time to short circuits. Circuit breakers are another type of overcurrent protection device that is commonly used in air conditioning and refrigeration equipment. Circuit breakers are electromechanical devices that automatically interrupt the flow of current when an overcurrent condition is detected. They consist of a bimetallic strip or a magnetic coil that responds to changes in current. When the current exceeds a predetermined level, the bimetallic strip bends or the magnetic coil activates, causing the circuit breaker to trip and interrupt the flow of current. Circuit breakers are available in a variety of types and sizes, including thermal magnetic circuit breakers, magnetic-only circuit breakers, and electronic circuit breakers. Thermal magnetic circuit breakers combine thermal and magnetic sensing elements to provide both overload and short-circuit protection. Magnetic-only circuit breakers respond only to short circuits and are typically used in applications where overload protection is not required. Electronic circuit breakers use electronic circuitry to detect overcurrent conditions and trip the circuit breaker. The advantages of using circuit breakers include their resetability, their ability to provide both overload and short-circuit protection, and their availability in a variety of types and sizes. The disadvantages of using circuit breakers include their slower response time to short circuits compared to fuses, their susceptibility to nuisance tripping caused by transient overcurrents, and their higher cost compared to fuses. The selection of the appropriate overcurrent protection device depends on a variety of factors, including the equipment's nameplate ratings, the available fault current, the desired level of protection, and the specific application requirements. It is important to carefully consider all of these factors before making a decision. In some cases, it may be necessary to consult with a qualified electrical engineer to determine the appropriate overcurrent protection device. The NEC provides detailed guidance on selecting overcurrent protection devices for various types of equipment and applications. It is essential to consult the NEC and other relevant standards to ensure that the overcurrent protection system complies with all applicable requirements. Regular inspection and maintenance of overcurrent protection devices are essential to ensure their proper operation. Users should be inspected periodically for signs of damage or deterioration. Circuit breakers should be tested regularly to ensure that they trip properly under overcurrent conditions. Any damaged or defective overcurrent protection devices should be replaced immediately. Proper overcurrent protection is essential for the safe and reliable operation of air conditioning and refrigeration equipment. By following the NEC requirements, the manufacturer's instructions, and good engineering practices, it is possible to create safe and reliable electrical installations that provide adequate protection for people and property. The 2002 NEC, along with subsequent editions, provides a comprehensive framework for electrical safety, and it's imperative for electrical professionals to stay updated with the latest revisions to ensure compliance and maintain the highest standards of safety.